We're joined today by Dr. Scott Smith from here at Johnson Space Center. A big part of the work that's done on the space station is trying to figure out how astronauts react to living in microgravity. And one thing in particular that some of the experiments on board the station look at is what nutrition can do to help with that. Dr. Scott Smith is with the Biomedical Research and Environmental Sciences Division here at Johnson Space Center. He's going to tell us a little bit more about that. Thanks for joining us, Scott.
Sure thing. Good morning.
Good morning. Well, why don't we start with why nutritional needs would be different in space than they are here on the ground?
Well, it's a good question, and obviously the answer is that, when astronauts go into space, it's a very unique environment. There's a lot of things that are different about spaceflight than there are on Earth. Besides the microgravity, the cabin air that they breathe is different, the way they exercise is different, the radiation exposure is different, and your body does what you pay it to do, which is it adapts to live in that environment. But what happens is in that adaptation, it requires different things. And, your skeleton is different, your muscles are different, your cardiovascular system works differently. And again, I work in the nutrition area, and, nutrition is how your body fuels all of those systems. So trying to understand how those requirements change and how we can use nutrition to help mitigate some of the negative effects of spaceflight is at the heart of what we do.
So it's important. You can actually change the way that the astronauts react to microgravity by changing their diet, basically?
That's correct. Obviously, again, in broad strokes, what we're trying to do is see if we can use diet as a way to mitigate the bone loss of spaceflight or the muscle loss of spaceflight.
Okay.
So it's not just simply, eating to maintain, everyday life. It's you're trying to overcome this environmental challenge that you've got.
Okay, and I know there are a few different experiments going on. I think one of them is biochemical profile. Can you tell us a little bit about that one?
Well, the biochemical profile is, I guess, it depends how you look at it. It's sort of a simple experiment. And what we're doing there is we're collecting blood samples and urine samples occasionally from the crews, and we measure a whole host of chemicals in those samples. So we can get a snapshot, if you will, of markers that tell us about nutritional status, vitamins, minerals, proteins. We also get markers of bone metabolism. We get markers of oxidative stress and changes in oxygen metabolism. And by looking at all of those chemicals over the course of a mission, we can look at how things change during flight. We can look at that in relationship to what they ate or what they did. And it allows us to have a database, if you will, to go back and look at if there are issues that come up with individual crews or groups of crews.
And so that one's going on right now. I guess you don't have that database yet. You're building it.
That's correct. And the biochemical profile experiment started last year, and it was an extension, if you will, of an experiment we flew earlier called the nutrition experiment. And that was the same sort of thing. It's been a little bit different. But so we've been collecting blood and urine samples on crews since back on Expedition 14 in 2006. So we've got a fair amount of data, but indeed the biochemical profile is new, and we're still working with those.
Okay. And then I guess there's another experiment called Pro-K that is actually completed, right?
Our last crew member has come home. Indeed, he landed. Reed Wiseman was our last subject. He landed in November, and even though Reed came home, some of his samples are still on board station. So we're anxiously awaiting SpaceX 5 to come home, because that's the way our samples get home at this point.
Okay, so it's still a little early, I guess, to tell us, what the results are. But can you tell us a little bit more about that experiment, how it was different?
The point of that study, again, as you mentioned, it was called Pro-K, and what we're getting at there is the relationship of animal protein and potassium in the diet. And the chemical abbreviation for potassium is K, so that's where we got the name from. And what we maintain is that the higher the ratio of those two things in your diet, the worse it is for bone. So in short, the more red meat you eat and the less fruits and vegetables you eat, the more bone loss you'll have. And what we set off to study is if we could use that as a way to mitigate bone changes during flight. So we would feed crews for a short period of time, 4 days at a time. We would feed them a diet that was either high animal protein and low potassium, or the other way around, low animal protein, high potassium.
Okay.
And then we looked at the difference in the way their bones were metabolizing and the calcium metabolism as a result of those diets.
Okay.
And again, it's still preliminary, but the initial data we've seen so far are encouraging.
How so?
Because we're seeing what we expected, which is always a good
Oh,
thing with an
yeah, that's
experiment,
nice.
that things line up the way you expected. And that is, again, that the higher animal protein to potassium ratio diets were associated with more higher bone breakdown,
Okay.
and
Well,
conversely. And I will tell you also, though, one of the things we found, which was a little bit of a surprise, is that it seems there are many factors that also involve bone. So one of the things that seems to be contributing to the results of the study is that the carbon dioxide levels on board station, in the air that the crews are breathing, seems to be a confounding factor. That with higher CO2 levels, the diet doesn't seem to have as big an effect. And that's one of the things we're waiting on our final sets of data to be able to really go in and dig at that. But
interesting.
it's intriguing.
So, is there something that you could do with that information? Just do you keep adjusting the diet, or I guess you can't really adjust the type of air they're breathing?
Well, there's a couple things we can do. I mean, obviously, we make dietary recommendations to crews all the time of, here's how much protein you should eat, and here's, try to get more fruits and vegetables, those kinds of things. As we look towards exploration, one of the things that we can drive is ambient CO2 levels, carbon dioxide levels in the cabin, so that indeed it's hard but not impossible to change the CO2 levels on board station.
Okay.
Again, as the engineers are off building the next vehicles,
They can take that into account.
knowing that the environment can affect bone, can help provide them with guidelines to help make things better.
Great. Well, what about for us here on Earth? Are there any implications that something like this would have for us?
Indeed, and in many ways, I think everything we do has implications on Earth, in part because we're studying a generally very healthy group of individuals, and we're putting them in a very strange environment. So the bone loss, for example, that we see is very similar to people with bone diseases on Earth. The difference is that we see it much faster than you see it on Earth. So we can study it over a shorter period of time. We can study ways to counteract it over a shorter period of time.
Interesting.
So on a 6-month space mission, for example, we see about the same change in bone that you would see over about 5 years in somebody on Earth. So it allows you to do sort of a rapid look at those changes.
Okay. Well, it sounds like a fascinating project.
Thanks.
I hope to hear more about the results as you've finished gathering them.
Thanks.